Hello. Hello. Can you hear me? Okay, we will start the meeting within 2 minutes. Let me join. Okay, let me share my slides. So today we will discuss eight assignment. Okay, here is a contribution just on the eight assignment. So we will discuss first the fraction from the cluster. Let's see in the figure. First, you can see first ray is an incident, then scattered by the atom A, position A, which is shown by A days. Similarly, second, and this is the atom reflected by 2 days. Like similarly, 3 and 4, so on and so forth. Okay. So see the phase difference between, we know the phase difference from the any ray, any optics ray or electromagnetic ray, phase difference given by 2 pi into the here is a HKL and UVW, which is this is the position. So HKL are the integer, let's say, so which is 2 pi into x. We know 2 pi into delta x. Phase difference. We know this is simple, and where from the any we can express the scattered wave from these atoms as, let's say, this is amplitude with power 5. Where is 5? We can put this 5 from here, 2 pi iota is an imaginary number 2 pi x, which is HU HKV plus LW. If the unit cell is consists of an atom, then we can express by this is an atom for different HKL 1 to n for HKL. So this is the structure factor. Please remember, from the atom is scattered by the atoms. Okay, so we will discuss the question on that, but let's see the more the integrated intensity HKL, intensity peak area of the powder deflection peak with the similar indices HKL is given by the following expression. We can see intensity is squarely intensity is proportional to the amplitude square. So similar scattered amplitude and multiplicity, Lorentz polarization factor, also temperature factor, absorption factor. So these are the factors which is dependent on the intensity of the powder factor P. So we will discuss net scattering by an atom, which is defined by as shown in the formula. Amplitude of the wave is scattered by an atom, and amplitude by the wave is scattered one electron only. Okay, this is there is explaining here. You can read. And next is multiplicity. We can say cubic as a phrase is, let's say 100. So we can write like 1000001 minus also this. So multiplicity of these three are similar. So we can say multiplicity of these 6 for 100 like. Also we can see the multiplicity other is my 12. Similarly, we can see we generally cubic system where the Miller indices, let's say n1 and 2 are unequal. Of the multi prime is given by, let's say 1 1 1 0 1 0 0 2 1. These are the 6 12 24. Okay, so these are the given to you here. And also intensity powder pattern line ignoring temperature and absorption. Earlier we saw you. So simply we can write it like that I is equal to F square scatter factor P plus multiplicity 1 plus cos square 2 theta divided by sin square theta cos theta. So this is the first question. Let's see. The structure factor HKL is amplitude of the incident ray depend on amplitude of the scattered X-ray from the all atom in the unit cell, the angle of the scattered, the wavelength of the incident ray. Please try to give me the answer. Choose your option. Yes, please. As we see in the first slide, what will be the answer given today? The scattered scale this will be defined by the amplitude of the scattered X-ray from the whole atom in a unit cell, not from the incident ray or the scattered angle. This is amplitude. I think this will depend by the answer is B, which we can see. These are the all atom are included here. Let's see the next question. If the atom are identical Add 0, 0, 0, the structure factor. Please calculate the structure factor. You can check comments for this question, but try to solve as we discussed. F equal to summation of, let's say, j, where j to n to the power 2 iota h to use this formula. Please try to solve this question. You can take 1 minute or 2 minutes, but tell me the answer. Did you get your answer? Let's see. U V W is 0, 0, 0. Position are given. So let's say. So only the atoms are only the at position. If we put 0, all things goes to 0. By either this is due the one. So, okay, let's see the next question. The first three peak in the XRD. The first three peak in the XRD pattern of the FCC structure material are present at the. What would be the answer of the present at the first three peaks in the XRD pattern of the FCC material are? Please choose your answer. center cubic. Let me tell you how can you determine the things. You know the structure factor summation over 2 and atom. Sorry, I would have written it right. H. This is your V. This is the expression for this. Let's see per center cubic. Can you calculate for simple PP this structure formula? Body center, per center. Let me give the first. Let me calculate for you first. Then you will please calculate these two. Simple cubic. You know the simple cubic atoms are at only the corners. You know. So let's say this is XYZ, and let's say the whole atom contribution at 1 by 8, n equal to 1 by 8 into how many corners? 8 would be the 1. And this atom would be, let's say, on with the corner position. Position is that. Now we can calculate this structure factor here. Only the one atom, so summation only with the one 4. So we can write like that. Simple 0 0, this is 0, it's equal to pi, and this is multiplied by 8. So for that, let me comment here the quotes. Answer is you have to see, but you have to calculate. H0, so this is supposed to whatever HKL, whatever the HKL on always present, XRD pattern reflection always present for all HKL, all HKL apart there, whatever the HKL always structure factor is present at. Similarly, you have to comment on body centered and head centered. Try to solve this accordingly. Let me tell you the structure first. Body center, you can, let's say XYZ, one at 0 0 0 position, another at center atom position will be half from the x-axis, half from the y-axis, half from the z-axis, z-axis. You know, so only two atoms are for the contribution of two atoms for in the body center, that is all the atoms. These are the position of this calculator, and let me know the comments on that. Similarly, presenter, please find the position of the atoms and calculate by yourself. You can take 5 minutes for this question, but please try. This is the best of the structure factor. Yes, please your answer. As we calculate simple cubic, similarly we have to find for the body center and face center. So let me clear this first. This is the structure factor formula. You have to apply this formula. Let me show you for body center and face center also. This cost. We know the items, two items are for body center. Let me put the first 0, 0. When we put first this item, let me 0, 0. Similarly, it will cause 2 items. If atoms are same, if are different, then we can put A and B. This is A, let's say atom on the corner A, and at the center is B. So this is amplitude would be different. So 0, 0, when we put 0, or this is for this atom. Similarly, for B atom, half, only H, K, L. Okay, this will be, this is 1, so this is only 2 pi atom. We can take common 2, H, K, L. This is we will power pi iota plus HK. So let's comment on it. If first let's assume the A and B are same. So FA and FB. If this number will be give you 2, 1, let's say this, then this is 2F or F 2F plus B, FF plus FB. If this number is given -1, and let's say we are same, then this will be 0. This will be 2F. So when will you give this in power pi iota? When will you give 1 and -1? You have to comment on H. It's K plus F. It will power. Let's say this is formula iota theta cos theta plus iota sin theta. Let's say put 2 pi theta equal to 2 pi sorry, cos 2 pi iota sin 2 pi. Sin equal to 0 and 2 pi could be 1. So only this number is 2, H plus K plus L. You can say this sum, if always sum should be even. Even pi, multiple of even pi always give you the reflection, but if in the case of pi, this is given to you -1, then is odd, then reflection or absent. Okay, so clear to you. Similarly, you have to calculate for which center, press center, and finally for test center. So let me show you the result. To calculate simple cubic, all HKL are treated. Body center, we know the body center when are present. HKL are even for different to occur, no reflection forward. As we calculated, this is given to you 0, this is given to you 2 or something non-zero. For FCC, we have to now comment on this. How you can calculate for this? Let me tell you the position. Let's say this is the axis XYZ. For face center, atoms are at corner as well as at face center. So this, let me choose the 3 only faces at the center, and tell now you can, let's say this face and edge and edge sharing, so in 3 1 by 8 and 8 corner would be 1 and position will be 0 0 0, and first nearest C base, we know the 6 base, and sharing is 1 half. You know 3 at 1 and position would be, you know, the red one only at the feathers. Let's say this is only XY plane. This position X will be half, Y will be half, and Z will be 0. And this is for X and Z, Z. So what will be the position? X, Y, 0, and Z. And similarly for that, only Y set. These are the position. Now you can put these number in this formula as we seen earlier. Summation over Z to N Fj equal to pi I H U. So these are the UV. You can put on this formula and you will get the non-zero number. Even HKLR must be unmixed. You can solve as we solved earlier, and the fraction will occur only or are even or all are odd. If HKLR mix, then we will solve this factor is 0. Then if this is factor is 0, then the fraction is not present. So you can see this the first three peaks in the starting pattern of the associated structure are. Now you can see, check the option which is unmixed. All are either even or either odd. So let's see. These number, check yourself first. This is odd even. Okay, similarly you have to find out, And first three T's. Also remember the first three T's for the FCC. First, this is even, this is odd. Sorry, this is odd, this is even, this is even. So we can say this is either these blends are even or unmixed. So D is a preferred answer according to the description and first it is. Also other methods are also, but first method you can check by these conditions. Now we have to choose the statement. We need to choose the statement which of following is are not correct statement. Expectation from the system. Let's read the options. Intensity of the peak is proportional to half of the square of the structure factor. Structure factor depend on the unit cell and size. Structure factor depend on the position of the unit cell. Structure factor is independent of the element in the system. We have already discussed this in the first 1, 2, 3 slides. Now we have to choose the right option. So intensity of the peak is proportional to half of the square of the structure factor and structure factor depending on the unit cell second size. As we can see from the lecture, unit cell of the unit is this is the expression of structure factor and it is also well described by the unit cell. This is also the dependent amplitude of the factor by an electron. Intensity is part of the structure factor. Let's see the next question. This is now question in quadrant diffraction experiment using over Kalpa. Radiation of wavelength is wavelength would be given 0.154 nanometer. In the first 5 Ps are observed from the monochrome crystal when the angle is 38 is 38.2, 64.4, 77.2, and 81.4 in degree. What is the crystal of the material? Center having cubic crystal cubic. How can we calculate? In last, we have discussed in separate assignment how to solve this type of question. Do you have any idea how can you calculate these things? Any comments? Okay, no comments. Then let me proceed. First, we have given 2 theta. So 2 theta, then calculate theta. This is the procedure. Sin square theta. So theta is 38, 54.2, 64.4, 77.2, and 81.4. These are the two theta. Now calculate theta half of that, 19. And that is now calculate the sin square theta, sin 19. You can use the calculator. It would be 1.5, sorry, 0.059 something. And sin square 28.1, it would be, let's calculate this. Into the 25 and 32.2 and 38.6 and 389 and 40 point. Okay, now we have to use this strategy, sin square theta, sin square theta divided by, sorry, sin square theta minimum. Which is the minimum? This is. So when we divide the same number, it would be around 1, and this will be 1.33, and now this is divided by this number, 2.67, similarly 3.67, and finally this 4.0. Now we have to multiply in such a number these things, sin square theta, sin square theta minimum, that get approximate the integer nearest integer. Let's say multiply by 3. This would be 3 and 3.99, almost 4, 8.01. This is, and this is 11.01, and this is something. And now we know is sin square theta, and this is, as we seen earlier, is this thing is dependent proportional to the HK square. So it's 3 is there, 3, 4, this is, let's say, this is 11, this is 12. So HKL, now you can calculate HKL. 3, when the square is 3, 4, 2, 8, and 11, and finally 12. So now we are getting HKL. These are given. Based on that, we have seen if HKL are unmixed, even or odd, unmixed, then FCC. Now check, this is even or these are all odd. First is odd, this is even, odd, even, and unmixed, either even or either odd. So this is goes to FCC. Clear to you? This is lengthy question, lengthy calculation, but you have to calculate like that. Clear? Let's move for next question. Which of the following characteristics of the material can be accurately determined by using X-ray technique? These are the options. Sorry, slide is not moving. Vacancy concentration in the material, identification of the phase in the materials, determination of the strain in the crystal, atomic size measurement. Which of the following characteristics of the material can be accurately determined by using X-ray diffracting technique? What will what will be can accurately calculate by the XRD? Let me show you. First, we can identify the phase in the material, and also second is the strain in the crystal. We can accurately calculate. As we can see from the application from the lecture, phase identification, determination of crystal size, the strain lattice, beginning, advanced texture. Now we can calculate also the atomic position, texture, and crystal quality. Next question: which of the following is the diffraction condition for the diffraction from the body center tubing? That is, we have calculated this already. Now please give me the correct answer. Yes, please tell me the answer. We are getting like that condition. Let me write down. A plus a by electron like that. Now we can, after we putting the 0, 0, 0 and half, 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 we are getting this expression finally. In a summation over, let's say, j to n fj per 2 I h in this equation. Now, when this number is, this whole app is non-zero, not equal to 0, when equal to 0. If this is give to 1 and minus 1. If give minus 1, then 0. If give 1, then non-zero. So h scalar h plus k plus n. If sum is even, multiple by even pi only give the 1. If odd pi give the 0. Now you can comment now. Please choose your option now. HKLR must be even or must be odd. If we want to the diffraction from the decision. Please write your answers. And we can see odd, give the sum is odd, then we get 0, means no amplitude distribution. So sum of the HKL is 0 or must be odd, then we are not getting. So this is not getting, but when we are even, then we are getting. Okay, when we zero, when we do n from here. Clear? This is conditional again. Now next question. The powder detection experiment using copper cable for addition of beryllium is 0.179 nanometer. What is the detection? What is the detection angle for the first order n equal to and HKL are given set of lengths from the body center cubic structure iron with lattice parameter are given. Now we have to calculate theta. 2d sin theta. You can use the rho and lambda. N equal to 1 is given, lambda is given, and you have to calculate theta and lambda, and you can use for the equation formula for body center HKL are given 220 HK and A is also given 2866. All things are given. Now please use this first formula based on given information. Use these all information in first formula. Please calculate this. We can take 5 minutes for this question, but please solve. You have to just perform the calculation, nothing else. Please answer. So you can use S D to design this is theta n equal to 1 and then will be in nanometer. Also you can put K and HKL to into 0.2866 in nanometer. This is 2 square, this is 2 square, this is 0 square. And sign. So this is multiplied by 1. Now we get 179. Both sides are nanometer, cancel out. Sin theta 179. This is 2 this number and 2866. You can take sine inverse this number. Please calculate this number as we calculate from 0 from something at 4 0 sine inverse. Now this is theta 124 pound and 3 also, which is a option F. Yes. Are you checking your answer? This is right. Clear? Let's see next question. Which of the following are the zero dimension defects? Grain boundary, Softy defects, interstitial, missing atoms. From lectures are as discussed. Point defects, missing interstitial, substitution of atoms, Funkel's, Softy defects. So B, C, and D are the correct option. See the next question. Which of the following are the referred to as equilibrium thermodynamic defects? Dislocation, grain boundaries, vacancies, throat defects. Yes, please. So answer C and D vacancies of 0. We can see zero dimension. Once equilibrium, zero dimension, we have already seen. So T and vacancy are in the zero dimension, which is point defects and equilibrium. And equilibrium. So defects is yes, please definition of the defects where of the ion vacancy and ion interstitial or the vacancy of the interstitials ion cation ion vacancy. These are the four options. Please choose your right option. Sorry, this place is not. This is vacation. See. So pair of anion and cation vacancies. So here ionic fluids which are present in. So this is the question on best Find the equilibrium of vacancies in 1 meter cube of copper at 1000 degrees Celsius given the density at 24 gram per centimeter cube. Atomic activation energy 0.9 electron volt per atom. Atomic weight is given. Now we have to calculate the vacancies. Let me tell you the formula. N by n. This is exponential and kT. These are given, and Q activation energy is already given. Electron volt per atom, and temperature is given. We have to calculate the density. How you can calculate? Is small n. Atomic code. This is Avogadro number and atomic weight, density. These are the formula. Please calculate. Then put in this equation. You have to find out n. These things are given. You can check for this question is up to 5 minutes. Try to solve this question. Such type of question can be asked in exam. So please prepare such type of exam questions. Please answer. Did you get answer? So density is already given in this question. What is that? It's at 0.4 gram per centimeter cube. You know the Avogadro number 23, and atomic weight is already given, which is 63.5 gram per mole. After calculating that, you will get size. Okay. Now apply this formula in an exponential qt upon kg. So this is capital M. So for this, an exponential qt 0.9 and critical k is at 0.62, we know, and from -5, and the capacity is already given in 1000 and using Kelvin. So 273, you can add this, which is in Kelvin, this 1273. So calculate this number, you will get around 25 vacancies. Okay, so this is just calculation, just question. Let's check the next question. The theoretical ratio of the intensity of the first two peaks in the exotic pattern of DCC structure material is. So answer we have checked this. We know the intensity, let's say two peaks. First two peaks, let's say first and second peak. These are the two peaks according to the two theta. We know the for bodies related to the first sum should be even. So we can prepare and second peak according to the sum should be even of HKL plus. Putting this number in this equation, we are getting square of 2 and 4, you know, and can we take the ratio? It would be half, or we can check by the also calculating the D. This is amplitude square intensity proportional to. Similarly, we are getting half. These are the two methods. Next question. Which of the following is true for the S dislocation? So as dislocation, you can see dislocation line perpendicular to the visibility and the motion of the S location can parallel to the visual. Okay. Yeah. Perpendicular one and there is parallel. The pressure vector of the dislocation in the case of CC, that is cubic crystal lattice. So answer will be half. You can see pressure vector for 111 half is the and cubic center. S is location is 111. So next question, let's see. An element having FCC crystal structure has a lattice parameter of 3.57 angstrom. What is the magnitude of the pressure vector? FCC A is given. You can use this FCC formula directly A by 2. So when you take them, we can take the mode of these things. So A is already given, magnitude of A. Please calculate this number. In angstrom divided by root 2. Tell me the answer. Hydrating 2.5 to angstrom. So answer is 2.5 to angstrom. Okay, next question. For BCC, body center cubic, ASM. Please calculate this. Body center cubic. For BCC, body center cubic, you have to take the roots of this. Root of this is square. Root 3 by 2. So this is already into same magnitude. Now we can put the value of A. What it is? Please calculate. It will be 0.9 minus 10. In angstrom, in meter or already in angstrom, frequency. Next question. The copper share modules of the lattice parameter 30 gigapascal and 3.65 angstrom lattice parameter respectively. What is the elastic strain energy per unit length? The dislocation line in copper. You can use the formula for energy. E is half Z B square. G is given 30 gigapascal and B you can calculate. For that we have already calculated copper cell module. Copper has a structure FCC by 2 the whole square. We can use. Please use this formula We have A and G. Please calculate this number. This would be, we putting the number. This is 30 and this is B square. You can calculate B square 10 minus 20. Okay, it would be 9.9 10 minus 10. Please check this number is correct or not. Next question. The structure factor order of CCl will be. You can assume one as CS and Cl the center. Sorry, this is should be chlorine. This is CS. Yes. And now we can calculate. Let me give you clue. This position is up, and CS is 0, 0, 0. Use this and put in this formula and tell me the answer. 2 pi H. Yes, please use this formula. Please calculate this. Let's put 400 FCS. We will get 0 things. And similarly for Cl minus, this is Cl plus. This is e to the power 2 pi iota and half e to HKL. So condition is that If this sum is even, then when HK are even. If all, so according to that, C then is even and is odd answer. So let's see the microstand measurement is given here. Instrument sum has instrument error, which is first. Then ideal function should be the additive function, but some instrumental function, instrumental error, the slice size, and the strain in the film are present. So this is the idea of the microstain. The ideal microstain crystal spacing are uniform, so the X-ray is scattered by the atom plane interface constructive at a specific well-defined angle leading to the subtraction peak. Okay, so read this, and so we can calculate by this low H standard equation crystalline size beta total equal to this is crystal at size, this is microstat HK. Okay, so this is full bit for maxima, which is beta. Can put full bit the total peak of the protein in the red one, dark angle. These are all things are given to you. You can use this formula based on the XRD. Use this formula. We can calculate this UH plot, dimensional plots. This is intercept at y-axis and the slice size is theta. Slope we can divide the microstand. Can divide the slice size. Okay, these are the information we can collect from the UH plot. Now this is the last question. Peak broadening video instrument resolution indicates, as we seen in this slide, after that instrument macrostand, microstand, point defects only latest parameter only here. What could be the reason? Please tell me the answer. So answer will be D. Microstrength was distribution of the day specimen roadmap. As we see, idle should be delta, but the instrument and microstrength coordinate microstrength. So this is all about today. So if you have any question, you can ask. We we will summarize all the things tomorrow from the same time 6 to 8, from 1 to 8 assignments. If you have any doubt, any query regarding the exam, you can ask that. Please be available. Okay. If you have any query, any answer, any question, you can ask. On 17th, we will discuss 1 to 8 assignments, all things, in a one lecture in 2 hours. Please be available. We will summarize all the things. Thanks. If you don't have any doubts, let me close the session.